Hi everybody. Today's video is on a topic that's very important to technical drawing called multi-view drawing. In a multi-view drawing, we take an object that's usually three-dimensional, like the bus that we see here, and instead of showing it three-dimensionally, we break it down into what we call multi-views. And a multi-view might be if we drew a front view, a top view, a side view of this bus, rather than showing this 3D view that we have here. So in this slide, I've taken the bus and I've drawn a front view here and a top view above it, a right side view, a left side view, a rear view or back view, and a bottom view. Now, I want to point out a couple of things about this, that the front view is not the front of the bus. But when we're talking about technical drawing, the front view is usually chosen because it's the principal view. And by that I mean the view that would probably show the most about the object. So the right view over here is actually the front of the bus, but the front view, which is the side view where the door is, I felt like showed the most information about the bus, so I chose it to be my front view. A lot of times when I'm talking about the front view, I just call it the principal view. We take the front view and we rotate it 90 degrees to the right, and that's how we get a right view. We take the front view and we rotate it 90 degrees toward the top, and that's how we get our top view. We start with our front view and rotate it 90 degrees to the left, and we get our left view, and so on like that. Now, there are 6 regular views of an object, and the regular views are the front, the top, the bottom, the right, the left, and the rear. But it's important to note that drafters only draw as many views as are needed to describe the object. So the reason why I've presented all 6 views of the bus is because each of these views presents features that the other views do not provide. And so if I were drawing the bus, I might draw all 6 views. And one thing I want to do is I'm going to go back one slide. And you can see that while the 3D view gives us a lot of information about the bus, the 6 multi-views give us all of the features of the bus. And this is why this has evolved over time, is the way that we do technical drawings, is that instead of giving the 3D view, we generally will decide, well, what would the front view be, or the principal view, and then rotate that to a top if that's needed, or rotate it to the right 90 degrees for a right side view. Now, multi-view drawings are also used in other fields like architecture and civil engineering. Here's an example of the front and the left and the right side views of a small house, and we refer to these views as the elevation views when we're talking about the field of architecture. The top view, where we take the front view and rotate it 90 degrees to the top, is not an elevation view, but in architecture we call that the roof plan. So I'm going to show you this house three-dimensionally and give you an idea of how a drafter might draw the elevations for the house. So first off, you have to have a concept of what the house would look like as a 3D object. Then we're going to go to its front view. So I want to go back to my 3D view, and so in the front view, all we're going to see are these planes that are shown on the front side of the house. So here's my front view. From the front view, I can rotate it 90 degrees to the right, and there is the right elevation of the house. From that view, I'm going to rotate back to the front view of the house, and then I'm going to rotate 90 degrees to the left, and there's the left elevation of the house. I'm going to rotate back to the front view, and again, if I rotate to the right, there's the right side view. I'll go back to the front. Now, a minute ago I said that if you rotate to the top, you get what we call the roof plan. So I'm going to click on the top view here, and we'll go and look at the top view. So here's our roof plan. Now I want to come back to the front view. And so you'll notice that this roof plane comes up and this roof plane comes up, and right up here they come together at the peak of the roof. So when we rotate to the top view, that peak becomes a line, and we have a plane that is going to the left and a plane that is going to the right. And if we think about this three-dimensionally, this is the high point of those planes, and they are running downhill, and the low point would be over here. The high point on this plane would be here, and it runs down in this direction. Those planes, because they're at an angle, and our point of view when we look at these is not perpendicular to those views, we refer to those as inclined planes. Now I'm going to come back to this view. So that's the edge of the inclined plane, and this is the edge of the inclined plane over here. The surface that's highlighted right now, our line of sight is perpendicular to this surface. And when we're perpendicular to a surface, we use a term called normal to the view. So we are normal to the view of this plane here. We are normal to these eaves right here. When we go up here to the top view, our line of sight is not perpendicular to this plane or to this plane. So we are not normal to those planes. We say that those are inclined planes. We would be normal to the top of the chimney, however. So I'll go back to here. All right. Now, all right, so we're going to focus on an object here. And what I want you to imagine is that you are a drafter and you work for a company, and a designer has come into your office and they have handed you this sketch right here. And they've said, I need you to make a technical drawing of this sketch so that we can send it to a manufacturer, because I need to make 100 of these parts. So what your job is going to be is to create a technical drawing, and that technical drawing needs to have everything on it that the manufacturer would need to make this part right here. So your role is going to be to figure out what the multi-views that are needed to describe this part. And remember, I said multi-views are things like a front view, a top view, and a side view. So what we're going to use is we're going to be looking in this direction here and call that our front view. We will look straight down on the object and draw that as a top view, and we will look in straight from the side over here, and we'll call this our right side view. Later, once you have your views drawn, you could add dimensions to those. You could add notations. You could write what the material for this is, which in this case it's called cast iron. And hopefully when you're finished, you would have created a drawing that is correct. That is, that all these numbers on the dimensions would be correct. It's clear, complete, and easy to read. And the manufacturer of this part would have no problem using your drawing to manufacture this part. So in the next thing I'm going to do, I'm going to click on the isometric view, what we call an isometric view of that part. So let's imagine that this part does not exist yet, but we know that this is basically what it looks like. So if you're the drafter, you're going to think to yourself, okay, I have to choose a front view. And remember, that's interchangeable sort of with the word principal view. This is what I would select for the front view of that part. I think if I could only give someone one view of the part, that probably shows the most about the part. So I'm going to go back to here. So imagine that you're thinking, or that you have this part. You could choose any view you want to be the front view. I'm going to select this view here, and partly that's because I see this hole that goes through the part, and I also see this groove that's cut through the part. I see these angles that we call chamfered edges over here. I can see a plane here, a plane here. I can see this plane, and I can see that plane in the background over there. So I'm going to go back so you can see how what's going to be visible in the front view is this plane, of course this circle, this groove, and all that stuff. Excuse me. So I'm going to go to the front view, and if I start with the front view, my top view is going to be a rotation of that 90 degrees to the top. So there I have the top view. I'm going to go back to the front view. Now I'm going to do the right side view, so I'm going to rotate 90 degrees to the right. So you can see what the right side view is going to look. I'm going to rotate back to the front view. Now I'm going to go to the top view again and show you some hidden lines that are going to be in this. When we rotate like that, we remember that there's a hole that goes all the way through this part, and it runs from north to south. That hole runs through like this. The edges of that hole, you see these dash lines? There's a dash line here and there's a dash line there. If I go back to my front view, you can see that the very outside edge of this hole, which we call the quadrant of the hole, when we rotate to the top view, the edges of that hole create two dashed hidden lines. Now I'm going to go back to the front view, excuse me, because we're going to see that same hole, and we'll see the edges of it when we rotate to our right side view. So watch as I rotate to the right and watch what happens with that hole. So you see the hidden line that comes across here and the hidden line that comes across here. That's the top and the bottom of that hole. All right, let me go back to that. So you can see we're projecting from the very top, the quadrant here and the quadrant here, into our right side view. That's what gives us the hidden lines. We would also draw a center line all the way through the center of that hole. Now there's also a hidden line that goes right down through here, and that represents this plane where the hole begins. So when I go to the right side view, I'll go back to my front and go to the right, that hole, the edges of that hole begin right here where that plane would project down. I'm going to go back to my isometric view. All right, now I'm going to return to the lecture. So whenever we're trying to visualize what the front view looks like, we have to use our imagination and imagine what the part would look like in 3 dimensions. And then we have to choose a point of view that we're going to look at that part from. And so for our front view, we imagine that we are standing over here. And we are looking in the direction of this arrow. And we're going to see the planes and the features that make up the front view. Now, one of the theories of drawing multi-view, of making multi-view drawings is, imagine that you have a pane of glass between you and the object, and you're projecting the features of that object to the glass. And we refer to that glass as the projection plane. And our line of sight is perpendicular to this projection plane. Therefore, we say that we're normal to the projection plane. Now, you can look into the background and you can see the features that are projected onto the projection plane. And you see this plane that's highlighted in red. It projected up right in this area here. And because our line of sight pardon me, is perpendicular to this plane, we say that we are normal to this plane here. We're also normal to this plane on this side, which would project to here because our line of sight is perpendicular to this plane. We're normal to this plane here, so this would be normal. We're normal to this plane here that projects up to here. We see the true diameter of that hole because we're looking straight down the bore of that hole in our front view. So this is what the front view will look like. The next view we could draw is the top view. And so again, I'm going to take a piece of glass and put it between me. I'm going to imagine that I'm standing right up here and the object, and I'm going to look straight down in the direction of this arrow here and draw what I would see. So I'm going to project all the features that are in the top of this part up to my projection plane here, and then I'm going to darken those as visible lines and hidden lines and center lines. So you can see that there is a center line, a hidden line that runs here and a hidden line that runs here. Those represent the outside edges of this hole as it goes through. And then I've added a center line that goes right down through the middle of that hole. So you can imagine that you've got a center line running right down through the center axis of that hole. And so that's why we're seeing a center line right here. Now, a minute ago I said that if you're looking down onto an object or looking at an object and your point of view is perpendicular to a plane, we say that you're normal to that plane. But I want you to notice that this plane here, which projects up to this area right here, that is an inclined plane. So you are not normal to that plane. There's also an inclined plane on this side over here, which projects up here. So this plane here is also an inclined plane. You are not normal to that plane. One of the things about not being normal to a plane is this. If a plane is inclined or even twisted into a weirder shape, which we call oblique, there's a good chance that that plane will not appear to be true size and sometimes not even true shape in the multi-view. So we'll get into that a little bit later in the course. I want you to notice that this plane right down here, this kind of horseshoe shape, it projects up right up to here. Would you say you're normal to that plane? Well, you are, because when you look straight down, your line of sight is perpendicular to this entire plane. So that would mean that this plane right here, that horseshoe kind of shape, is probably true size and true shape. Now let's look at the right side view. We're going to place a sheet of glass that's parallel to this plane here between us and the object. So we're standing over here. We're looking in the direction of this arrow right here, and we're going to project the features of the 3D object onto the two-dimensional projection plane. All right. So again, we can see the hidden lines coming across for the top and the bottom of this hole. We'll have a center line that runs all the way through that hole there, and we'll draw that. This edge here lines up with this edge here. So starting here and going up, this rectangle we see here is an inclined plane. So we are not normal to this plane here, but we are normal to this plane over here, which means we would be normal here. We have a hidden line that comes straight down here, and that represents the edge view of this plane here that is hidden. So it lies behind this part that sticks out, so we have to draw a hidden line, and of course that's where our hole begins. Now, one thing I want to notice about these hidden lines is that they begin at a hidden line and they end at a visible line. The hidden lines do not stick out into space. Center lines, on the other hand, will stick out a little bit, maybe a quarter of an inch or so. And so sometimes I think that confuses beginners because they think their hidden lines need to stick out into space, but the hidden lines have to end at the plane where the hole ends. Center lines can extend out past the edge about a quarter of an inch, or if you're in the metric system, about 6 millimeters. All right, so now that we've visualized what the front, top, and right side view look like, pardon me, the next step would be to sketch those up, and so that you can draw them later using AutoCAD or some other CAD program. So what I've done is I made a sketch of my front view, and I tried to sketch this sort of in proportion. I didn't really measure this or anything. I just tried to make it look like it's about proportional to what the actual object looks like. And if you remember from our 3D model, we had already visualized that the front view would look something like this. Pardon me. The next thing I would do is take my pencil and go to the features, like for example this top line right here, and just draw a light construction line across, and go to the bottom of that groove and draw a light construction line across. And you can see these construction lines. I've even drawn a construction line from the top of this circle across the bottom of the circle, the center line, the bottom edge. And I've done the same thing. I've taken the features and I've just drawn construction lines. And construction lines are just light lines that we draw up, because I'm going to use those construction lines when I sketch my right side view, which is over here, and when I sketch the top view. So I'm actually using these construction lines from this view that I sketch up and to the right to help me draw this. And whenever we create construction lines like that, we call that process orthographic projection. All right, so orthographic projection is used to create multi-views. Now I want to add another part of orthographic projection that's important. If you draw a miter line, which is this line right here, which is a 45-degree line, you can actually take a feature in the side view, for example, this edge right here, and project it up until it reaches that 45-degree line, and then project it across, and that will tell you where that edge is in this view up here. So you can project from the side view up to a 45 and across. So we could go to this back edge here, we could project up and across. That's where the back edge and the top view would be. But it works in the other direction as well. If I have the front edge of my top view drawn, I can project over until it hits the 45-degree line and then project down. And that's where the front edge of my right side view will be. I could also go back where this groove is cut out, and I could go to the back edge of that groove, project over to the 45, project straight down like that, and that's where I would see that hidden line, which represents that edge right there. So when we're using these projection lines and we're using the 45-degree miter line, we say that we're using orthographic projection techniques. All right, so now we have our front view, our top view, and our right side view drawn. And I wanted to just come back and point out again that we have visible lines, and sometimes visible lines are referred to as object lines. That visible and object are used interchangeably. We have hidden lines. You can see the hidden lines that represent the top and bottom of the hole, the hidden line that represents that plane where the hole begins. We have hidden lines up here where the hole starts at this plane, goes all the way through. And then we have center lines. So again, I said that center line can extend out about 1/4 of an inch past the edge of the thing it's the center of. So it's the center of this hole, so it can extend out about 1/4 inch. Over here, we have a center line that will run right down through the center axis of that hole. It can also extend out about 1/4 of an inch. Now, when we see a hole as a circle, like this right here, we add center lines to it, but we actually refer to these as center marks, and they look a little bit different from our center lines because what we do is we place a plus sign right in the center of the hole, and then we want to have 4 gaps around that plus sign, and then we're going to start a line that comes out about 1/4 of an inch past the edge of the hole. Like I said, with center lines, we generally extend them about 1/4 inch past the edge of whatever they're the center of. So we would start this line, bring it up about 1/4 of an inch past the edge of this hole, do the same thing over here, and the same thing over here. So we refer to all of those marks and those gaps that you have right there as center marks. And there's actually a center mark tool in AutoCAD that sometimes we'll use. Now, one thing I also wanted to point out about these different line types that we have here, like visible lines, hidden lines, center lines, is that there is a standard that says when you print these lines out, if you're drawing them on a CAD, using CAD, that your visible lines should print thicker than your hidden lines or your center lines. And the recommended thickness is 0.6 millimeters. Now, 0.6 millimeters is not too thick, but you can see that the visible lines here in this drawing are thicker than the hidden lines and the center lines. So the recommendation for hidden lines and center lines is to draw those 0.3 millimeters thick. And we'll get into all this later when we start drawing with CAD, but I think it's important to understand that we use different line weights. And line weight refers to the relative thickness of lines. So the visible line is 0.6, the hidden line is 0.3, the center line 0.3, so these are thinner. That is line weight. The type of line that we have, hidden, center, and visible, that's what we refer to as line type versus line weight, which is the thickness. All right, so we've drawn our front, top, and right side view using AutoCAD, and now we come in and we add all of the dimensions that were in the original sketch that the designer gave us, including what the material is. And if we've done our job properly, we should be able to send this drawing to a manufacturer, and because the person who makes this part has been trained to read blueprints, when they see this drawing, they will realize that this is a front view of our object that they're going to manufacture. They'll realize this is a top view and that this is a right side view, and they will recognize all these dimensions and understand what those dimensions are. And hopefully, if we got everything in there that the designer sketched for us, they should be able to manufacture that part, and they should be able to manufacture it correctly, and they shouldn't have to call us and ask us any questions or anything at all. That's what a successful technical drawing looks like. So we're employing multi-view drawing. These are our 3 multi-views to create a technical drawing that has dimensions, it has notations like what the material is, and anything else that would be required to manufacture this part. So let's talk about the assignments in Chapter 2. Exercise 2.1, which is near the back of the chapter, gives you 9 objects that have grids on them. And what your assignment is to go to the back of the book and carefully tear out a gridded sheet that looks like this and draw the front, the top, and the right side view of these objects over here. And in fact, in exercise 2.1, the first gridded sheet already has this view drawn here. And you're going to start those in the corners. You see these little dark squares that you have, or the little corners that are sketched in each grid. That's where you'll start your front view, would be there in that corner, and your top view would be in that corner there, and your right side view would be over here in this corner. There's even a miter line. Remember that 45-degree line that you can project up and across, or across and down. So we can use orthographic projection in this, especially because we can follow across on our grids. Now if you look at this first object, you can see this corner here. That's where you're going to start. But like I said, the first one is given to you. So if you count the grids over, you would count that many grids here. You would go up 2 grids. There's 2 grids here. You would come over 1 grid, and so on like that. So like I said, this one's given to you. So you're really going to be starting with number 2. And that corner right there would be starting right in this corner, that little dark corner that's sketched in there. You would sketch all 9 of those, and you would sketch the front, the top, and the right side view. So this is what your grid sheet will look like more at full scale. This is the one that's given to you. This is what your second project will look like when it's sketched. This is what the third, and so on. So as you sketch each of those parts, this is kind of what things are going to look like. Of course, yours won't be in color. Yours will be whatever color your pencil is. And you can see where I've started the front view. That would correspond to this corner here. The top view would correspond to that corner starting there. And this view over here, this corner here, would actually start in that corner. You can see the 45-degree line. So remember, if you start sketching the top view and you haven't sketched this view yet, you could take this back edge, project it over to the 45, and project straight down, and the back edge of the right side view is going to fall on that grid. You could take the front edge here over to the 45 and project it down, and you'll see it there. So this is what those look like. When you have all 9 of them on the same sheet, it will look something like this. After you're finished with that, there's exercise 2.2. You're going to do the same thing, but with some different shapes. And you would start sketching front, top, and side view right in here of part number 1. And you'll progress through until you would draw the front, top, and side view of part number 9 right in this area here. And one of the things about these objects that you're sketching, they'll keep presenting different geometric shapes for you to sketch, and that'll help you figure out what things will look like later on when you're trying to make sketches of objects that you're making technical drawings for. So here we can see what the 9 views will look like. Then exercise 2.3, this time you're introduced to cylindrical shapes. And so I want to show you that on this one, because you don't have a corner on this, you're actually going to imagine that, that where the corner of that circle, if you came straight down and straight across from the quadrants of that circle, where that would be, and measure over and up. I think the best way I can show you that is in the solution. So this is the corner where you're going to start measuring from, and you're going to count over 1, 2, 3 along this axis here, and then up 1, 2, 3, and that's where your center is going to be for all of these circles. So when we go back over here, you'll count grids to determine what the diameters of these cylinders are. So that small hole that goes through, I can see it's 2 grids in diameter. So if I go over here, I can see that this hole here is 2 grids in diameter. Then I would go to the top of that hole and project across, and that will give me a hidden line in the side view. I would go to the side of the hole and project up. That would give me this hidden line here. The side of the hole would give me that hidden line there, and so on. Like I said, what these are going to give you are these cylindrical shapes to deal with. And then we finish it off with some shapes that look like architectural shapes. And so you sort of have to deal with some roofs, and what I want you to imagine is that wherever you see a cutout, imagine that the cutout goes all the way through the part. So this is not really a window. It appears to be a window in this view, but it's actually a cutout that goes all the way through this block that looks kind of like a house. Problem 2.4 will present some more challenges to sketch the front, top, and the side view. Again, you'll just go tear out the grid sheet at the back of the book real carefully, and the grid sheets have a perforation along them, so if you're careful, you can tear those out. Your views will look something like this on exercise 2.4. 2.5, you can see things are looking a little more complicated. Your views look something like this. And the last exercise of chapter 2 is exercise 2.6. And this also has some kind of challenging sketches, but by the time you get to this sheet, you should have developed some skills that will help you out. The first assignment, exercise 2.1, is actually pretty easy. So with that, I'm going to end my talk about multi-view drawing. It'll be time for you to start on exercise 2.1. And if you look in Blackboard, you should be able to find some help with that. And so good luck.